All right, let's do some Mathity-Math. It says here, identify the roots of the quadratic. Okay, so remember, the roots of the quadratic are like the solutions or the zeros, or in other words, where does your parabola cross the x-axis? Okay, so the way we tackle this is we just need to isolate our x value and go from there. So step one, before we can even get to this term, we got to take a look at this. How do we move this positive 33 out of here? So we do that by just subtracting 33 from both sides, right? We subtract 33 from both sides, and those will zero out because 33 minus 33 is 0. And so now we have 3x squared equals negative 33. Okay, so far so good. Let's keep it moving. Now, again, our goal is to isolate x. Now, again, before I can get to this x, I need to talk about this coefficient right here. So this is 3 times x squared. Well, what's the opposite of multiplying by 3? Well, that is dividing by 3. And we do it to both sides because we just keep that equation balanced. That's just Algebra 101. So here we go. X squared is negative 11. All right, we are cooking. So now we are ready to tackle this x. And again, we're doing this whole game of opposites, right? Here we did the opposite of positive 33, which is negative 33. Here we did the opposite of multiplying by 3, which is dividing by 3. So now we want to do the opposite of squaring, which is taking the square root. So if we take the square root of both sides, this square root will cancel that square. So we get x is plus or minus the square root of negative 11. Okay, so, and this is where we get to an interesting situation, right? Because logically, if you think about this, taking the square root of a negative number puts us in quite a position here. And let me do like a sidebar, like a side thought here. Let's take a very straightforward idea, like square root of negative 4. Remember, this is just a side. Here, I'll just draw. This is just an idea I want to talk about that will not affect our answer per se. So we'll just kind of keep it over here, keep it like a thought bubble, okay? So this is saying, hey, what number do you multiply by itself twice to get negative 4, okay? So if you said 2 times 2, okay, well, let's try 2 times 2. If I did 2 times 2, well, I get positive 4. Okay, that didn't work. I'll do negative 2 times negative 2. Well, that gives me positive 4. That didn't work. And then you say, I'll do, how about negative 2 times positive 2? And yay, that gives us negative 4. But we didn't follow the rules. Because the rule says you have to multiply the exact same number twice. And these are clearly different because one is negative and one is positive. So that's not following the rules. So you can see here that you can never find the square root of a negative number, at least not in the realm we live in. But we can kind of journey to the imaginary realm, and that's where we're going to go with this. You see, there is an imaginary number. In math, it has been decided that in the imaginary realm, you can find a number, and that number is called I, and I stands for imaginary. And imaginary is the value of the square root of negative 1. So they're saying in this imaginary realm, there is a value that when you multiply itself will become negative, right? Crazy, hard to imagine. That's why it's called imaginary. Anyway, that value is the square root of negative 1. So whenever you get the square root of negative 1, you can represent that with I. It comes outside of the radical. So coming down here, if we break this apart, we can look at it kind of like this. We know that the negative of root 11 is actually the same as saying the square root of 11 multiplied by the square root of negative 1. And that makes sense because the square root of 11 times the square root of negative 1 would be the square root of negative 11. But by separating these out, it allows us to represent this as I, because we just said I is the square root of negative 1. So we rewrite this as plus or minus I, because that comes out, root 11. And that tells us that the roots of our quadratic, well, they're imaginary, Okay, and if something is not if something is imaginary, it is not real. So actually, the answer we're going to write here is no real solutions. And that's your answer. Okay, you write no real solutions, and voila, that's your answer, and you're done. All right, as always, please subscribe below. If you want to be notified when I make you more practice problems, and if you have questions or comments or something you gotta let me know, please leave a comment below, and I'll do my best to respond. Okay, thank you. Bye-bye.